The geometry of the universe. Have you ever truly tried to picture the shape of everything? Not just the Earth, or the solar system, or even our galaxy, but the entire universe. The sum total of all that exists, all that has ever existed, and all that ever will be. Most of us, we default to an image of an infinite black void, dotted with galaxies like a spray of diamond dust. A boundless, empty stage where the cosmic drama plays out. But what if I told you that's almost certainly wrong? That the universe is not a formless void, but a shape, a specific, definable, and breathtakingly beautiful geometric structure. Welcome. Today, we are not just looking up at the stars. We are going to step outside the cosmos itself and try to glimpse its architecture. We are going to explore the geometry of the universe. To begin, we need to shatter a fundamental assumption. We think in terms of flatness. The floor is flat, the horizon is flat. This comes from our ancient evolutionary need to navigate a small world. But the universe plays by different rules. Imagine you're a tiny, two-dimensional creature, living your entire life on the surface of a vast, perfectly flat sheet of paper. In your world, there is only forward, backward, left, and right. The concepts of up and down are as incomprehensible to you as a fourth dimension is to us. On your flat sheet, the rules of geometry are simple. Draw a triangle, and its angles always add up to 180 degrees. Send two laser beams perfectly parallel to each other, and they will stay parallel forever, never meeting. This is your reality. It's all you know. Now imagine that your entire world, this flat sheet, is not resting on a table, but is actually the skin of an immense expanding balloon. You, as the 2D creature, would never perceive the curvature. You're too small, trapped on the surface. But strange things would start to happen. If you were to draw a truly massive triangle, a cosmic scale triangle, you would find its angles add up to more than 180 degrees. If you sent out those two parallel laser beams on a long journey across the surface of the balloon, you might find that they slowly, inevitably, begin to converge. Your geometry has betrayed you. Your space is not flat. It is curved. This, my friends, is the first and most profound clue to our own universe. We are that 2D creature. We are trapped within the three-dimensional fabric of space-time, and we are trying to deduce the shape of the higher dimensional structure we are painted upon. So, what is the shape of our cosmic balloon? Cosmologists, those cosmic cartographers, have given us three primary candidates, three grand possibilities for the geometry of all that is. The first is the one that feels most intuitive, flat geometry. A flat universe is infinite. It goes on and on and on without end. In this geometry, the standard rules we learned in school hold true, but on a cosmic scale. Parallel beams of light stay parallel forever. The interior angles of a triangle always add up to 180 degrees. It is a universe of Euclidean perfection, vast and endless. In a flat universe, if you could build a starship with infinite power and travel in one perfectly straight line, you would never, ever return to your starting point. You would just encounter more and more galaxies, forever, in an endless sea of creation. It's a concept that is both liberating and utterly terrifying in its scope. The second possibility is what we call spherical geometry, or a positively curved universe. This is the universe as a four-dimensional sphere. Try to hold that image in your mind. Not a 3D ball, but a sphere in 4D space. We, living on its 3D surface, could never see the curvature directly, just as our 2D friend on the balloon couldn't. But the implications are magical. In a spherical universe, space is finite, but unbounded. There is no edge. If you got in your starship and flew in one direction, you wouldn't hit a cosmic wall. You would, after a journey of perhaps hundreds of billions of years, find yourself returning to your starting point from the opposite direction, like Magellan circumnavigating the cosmos. The geometry here is mind-bending. Think of the surface of the Earth. You can walk forever and never fall off. Now, apply that to three-dimensional space. In a spherical universe, if you could shine a laser beam powerful enough, and if you waited long enough, that beam would eventually wrap around the entire cosmos and hit you in the back. And the triangles. Draw a triangle on a sphere, and its angles add up to more than 180 degrees. Space is curved in on itself, a cosmic Ouroboros, a self-contained, finite bubble of reality. The third possibility is the strangest of all: hyperbolic geometry, or a negatively curved universe. If spherical geometry is like the skin of a balloon, hyperbolic geometry is like a saddle, or an endless series of interconnected horse saddles. In this universe, space is curved outwards. The consequences are bizarre and beautiful. In a hyperbolic universe, the interior angles of a triangle add up to less than 180 degrees. Parallel lines of light would not just stay parallel, they would actively diverge, spreading apart from each other at an exponential rate. This is a universe of exponential expansion, not just in time, but in space itself. It is a fractal reality. A hyperbolic universe is likely infinite, but its geometry is so wild that it has more surface area, in a sense, than a flat universe of the same size. It is a labyrinthine, cavernous cosmos where every point feels like the center of an ever-expanding web. So, the million-dollar question, which one is it? Which of these three magical geometries is our true home? The answer, according to our most precise measurements from satellites like Planck, is it's flat. The data, the cosmic microwave background radiation, the faint afterglow of the Big Bang, tells us, with stunning accuracy, that our universe appears to be geometrically flat. But, and this is a but of cosmic proportions, this is where the mystery deepens into something truly mystical. A perfectly flat universe, within the framework of Einstein's general relativity, requires a very specific, critical balance of mass and energy. It's like balancing a pencil perfectly on its tip. For it to be as flat as we observe, the initial conditions of the Big Bang had to be fine-tuned to an unimaginable degree. This flatness problem is one of the greatest enigmas in cosmology. Why is the universe so flat? The leading answer is a concept as fantastical as any geometry: cosmic inflation. The theory proposes that in the first sliver of a second after the birth of the universe, reality underwent a period of hyperexpansion. It ballooned from smaller than a proton to a macroscopic size, faster than the speed of light. Now imagine you have a crinkled, wrinkled piece of paper full of folds and curves. Now blow it up to the size of a galaxy. What happens to those wrinkles? They become vanishingly small. The paper appears perfectly, utterly flat. Inflation did that to our cosmos. It stretched the initial curvature of the infant universe so dramatically that any curvature from our local, limited perspective became undetectable. It smoothed everything out to the beautiful flatness we measure today. But here's the mystical twist. When we say the universe is flat, we are talking about the observable universe, the portion we can see from our tiny little planet. The entire universe, the whole grand structure, could be vastly larger. It could be infinite. Or our flat, observable universe could be just one tiny tile in a much grander mosaic. This is where geometry transcends physics and enters the realm of the magical. A flat universe doesn't have to be a simple, infinite plane. Think of a piece of paper. It's flat. Now, what if you rolled that paper into a cylinder and glued the ends together? The geometry is still flat. A triangle drawn on it still has 180-degree angles, but its topology has changed. It is now finite and wrapped around itself. Our universe could be like that. It could be a 3 torus. Imagine a giant cosmic cube. You pilot your starship to what appears to be the edge, but instead of a void, you find yourself seamlessly re-entering the universe from the opposite side. The sky would be a mosaic of repeating images. Look far enough in any direction, and you might see the faint, ghostly image of our own Milky Way galaxy, the light from our own sun having wrapped around the entire cosmos to come back to us. We would be living inside a cosmic hall of mirrors, a finite closed system with no center and no edge. But why stop there? The geometry could be even more complex. Perhaps our flat universe is just one brane, a 3-dimensional membrane, floating in a higher dimensional bulk, like a sheet of paper floating in a vast ocean. Other branes, other universes, could be floating just millimeters away from us in a higher dimension we cannot perceive. What we call dark matter, or other cosmic mysteries, could be the gravitational whisper from a parallel reality brushing against our own. This isn't just speculation, it's a direct extension of the geometric thinking we started with. And this leads us to the most profound, the most mystical implication of all. The geometry of the universe is not just about space. It is inextricably woven with time and with fate. A spherical, positively curved universe would eventually, one day, stop expanding and collapse back in on itself in a big crunch. A cosmic cycle of death and perhaps rebirth. A hyperbolic, negatively curved universe would expand forever, its galaxies spreading apart until the last stars burn out, and the cosmos becomes a cold, dark, and empty void. Our flat universe is poised on a knife's edge. It, too, is destined for a cold end, thanks to the mysterious force we call dark energy. But its flat geometry is the signature of its incredible birth. So, when we ask, what is the shape of the universe? We are really asking, what is the nature of reality itself? We are asking about our ultimate origins and our final destiny. The geometry is the answer. It is the universe's signature. We are not living in a formless void. We are living inside a cosmic structure of unimaginable beauty and complexity. Every star you see at night is a point of light on this grand architecture. Every galaxy is a brushstroke on this infinite canvas. The very space between you and your screen is not empty. It is part of this geometry, curved and shaped by the mass of the Earth, the Sun, the galaxy, in a delicate, invisible web. You are not just in the universe, you are of it. The atoms in your body, the neurons firing in your brain as you try to comprehend these vast ideas, are all part of this geometric tapestry. You are the universe become conscious, trying to look in the mirror and understand its own shape. It's a quest that began with the first human who looked up at the night sky in wonder, and it continues with our most powerful telescopes and our most brilliant minds. We are cosmic cartographers, mapping the shores of an infinite ocean. And the map, it seems, is a work of art. The journey to understand this is far from over. Every answer reveals a deeper, more beautiful question. If this journey into the cosmic architecture sparked a sense of wonder in you, if you felt that thrill of peeking behind the curtain of reality, then do me a favor. Like this video and subscribe to the channel. We are just getting started on this adventure, and I don't want you to miss what's coming. And I would love to continue this conversation. What do you think the shape of the universe is? Does the idea of a finite, wrapped around cosmos excite you? Or does the infinite void call to you? Let me know your thoughts in the comments below. For those of you who want to dive even deeper, to explore ideas of parallel realities, higher dimensions, and the true holographic nature of existence, I've written a book that expands on all of this. It's called Holographic Multiverse, and in it, we take these geometric concepts to their ultimate, mind-bending conclusions. If you're intrigued, the link to check it out is in the description below. Thank you for joining me on this voyage beyond the stars to the very shape of existence itself. Remember to look up at the night sky, not as a random scattering of lights, but as the illuminated surface of a geometry so grand, we are only just beginning to trace its edges. Until next time, stay curious.